Okay, we've been studying the relationship between two quantitative variables, x and y, and we've looked at scatter plots and the correlation analysis. And another way to see how x and y are related is to build a model. And so a regression analysis is a mathematical model or function that we can use to predict or determine one variable by another variable. So let's suppose we have the regression model such, and we have a linear relationship. So y equals beta naught plus beta 1 x plus epsilon. And epsilon is an error term because we know that the data is a random sample. And so we know then that there's some sort of error residual associated with it. So this is the regression model, and they are parameters that need to be estimated. And so how do we estimate them? We estimate them by using the regression equation. So how do we go from regression model to regression equation? Is using the method of least squares. So the least squares regression line is the regression line that results in the smallest sum of errors squared. And how do we do that? We do that by using y and putting a hat that denotes the estimate for y. And b naught estimates beta naught, our intercept, and b1 is our slope. It estimates beta 1. And so you might be wondering, well, what estimates the error? We will get to that later when we do the residual analysis. So we have our least squares regression line, and what we need to do to get those values is to calculate the slope and intercept. And here's how we do that. We have our slope, b1, and it's expressed in terms of new notation, sum of squares of xy and sum of squares xx, or ssxy, ssxx, and we'll get to those in a moment. It also equals our correlation r times those values. So remember, r is a value between -1 and +1, and we'll see how to calculate that as well. So we have slope and intercept. Our intercept b naught is a function of the average y's, subtract the slope, so you need to calculate the slope before you calculate the intercept, multiplied by the average x's. Once we have our slope and intercept, we can then put it all together. Y hat equals b naught, and that is our intercept, and then our slope b1 multiplied by x. What we can do then is put in values for any x, not just from our data, and then get an output or a prediction y hat. Okay, so going to the notation here, these are the new notations: ssxy, ssxx, ssyy. Once you have those three, you can calculate the slope, the intercept, and also the correlation coefficient r, which I was telling you you can also do. So these are what are given in the textbook, as well as these. These are what I use. It's just each x subtract the average x multiplied by each y subtract the average y. Another way to calculate the ssxx is the sum of the squares of the x's. So each x subtract the average x squared. And you'll notice that this is the numerator of the variance for x. And same here with the SSYY is the y subtract the y bar. So we have the sum of the squares for the y's, and it too is the numerator for the variance of y. Once you have those three quantities, you can then calculate the correlation coefficient. You can calculate also the slope and the intercept. Once you put it all together, you have your least squares regression line. So if you have all those quantities, you have your line. And we will look at an example of how to do that with some real data.